Hello fifth graders, it is Tuesday, February 16th. It is time to check our bell work. So you should already have this done and now you're just making corrections. And again, I do expect you to make the corrections. If you got it wrong, don't just leave it wrong, fix it. For the first three, I ask you to change each mixed number into an improper fraction. And remember, we do that by multiplying the denominator by the whole number and then adding our numerator to get our new numerator. And the reason we do that is because if you have 4 2/7, this 4 means that you have 7 sevenths 4 times. So 7 times 4 is 28, plus those 2 extra is 30. And we never change what it's out of. The denominator stays the same. For number 2, 3 times 12 is 36, plus 1 is 37 thirds. And for number 3, 10 times 2 is 20, plus 9 is 29 tenths. So that's what you should have for your first 3. Now we're going to do the opposite. We're going to change each improper fraction to a mixed number. So I want to know how many 5/5 there are in 12/5. So 5, 10, I can fit 2 groups of 5/5. So basically I'm just asking myself, 5 times what gets me closest to 12? Well, 5 times 2 does, which is 10, and then it takes 2 more to get to that 12. Our denominator never changes. For number 5, I have to ask myself, 9 times what gets me closest to 47? So maybe you're like, well, 9 times 4, 9, oh yeah, 9 times 5. 9 times 5 is 45. And to get from 45 to 47, that's 2 out of 9. And for 10/7, 7 times 1 is 7. And there are 3 left to get to the 10 out of 7. And you can always double check by doing what you did up here. 5 times 2 is 10, plus 2 is 12/5. 45, 47 ninths. 10 sevenths. It works forward, backward. Okay, time to solve. I kind of have some mixed things here. Sometimes you can cross simplify. Sometimes you can't. Sometimes you have a mixed number and need to change it. Sometimes you don't. So just is this a whole mix of everything that we've learned. So for number 7, I don't see any mixed numbers to change. I see a 9 and a 1 and an 8 and a 5. So I can't do any cross simplifying. So I'm just going to multiply across the top. 8 times 1 is 8. And 9 times 5 is 45. Now I did notice some people trying to change fractions like this into mixed numbers. Mixed numbers means you have more than 1. So if this were going to be a mixed number, that means my numerator would have to be 45 or more. I only have 8 out of 45. That's less than 1 whole. You can't change that to a mixed number. You can only change it to a mixed number if your numerator is greater than the denominator. Or if it's equivalent, then it just means is 1. All right, take a look at the next one. 2 and 15, there's nothing I can do, but 7 and 14 there is. 7 goes into both of those. 7 goes into 7 once and into 14 twice. So you end up having 2 times 2, which is 4, and 1 times 15, which is 15. 4 fifteenths is simplest form. There's not a number that goes into 4 and 15 other than 1, so you're done. All right, for number 9, I see this whole number here, so I'm going to put a 1 underneath it, and I'm going to see if I can cross simplify. 5 and 1, I can't do anything because dividing by 1 doesn't do anything. With the 3 and the 9, I can. 3 is the largest number that divides into both of those without any leftovers. 3 goes into 3 once, 3 goes into 9 3 times. So 5 times 1 is 5, and 3 times 1 is 3. Now this one I can change into a mixed number because I have more than my denominator. That means I have more than 1. So 3 goes into 5 1 time. And 3 times 1 is 3, plus 2 gives me that 5 out of 3. So you should have 1 2/3 for your final answer. For number 10, here's a mixed number. Remember, when you see a mixed number, we need to change that into an improper fraction before we multiply. So we do that by doing what we did for number 1. 5 times 1 is 5, plus 3 is 8/5 times 4/9. So this is the actual problem I'm going to solve. I see 8 and 9 and I can't do anything, and 5 and 4 and I can't do anything. I know that this 8 and 4, maybe you're thinking, well, 4 goes into both of those. I need to have 1 in the numerator and 1 in the denominator in order to simplify things. So you can't simplify them both if they're in the numerator. So we can just multiply across the top. 8 times 4 is 32. Multiply across the bottom. 5 times 9 is 45. And you're good. There's not a number that will divide into 32 and 45. Other than 1, and it won't change anything. Now I have 2 mixed numbers. We're going to change them both into improper fractions before we multiply. 4 times 2 is 8, plus 1 is 9/4 times 3 times 1 is 3 plus 2 is 5/3. That's what we just had up there. Okay, now I'm gonna look and I see a 4 and a 5. I can't do anything. However, 9 and 3 I can. We just had to do that too. 3 goes into 3 once, 3 goes into 9 3 times. So I'm left with 3 times 5 up top and 4 times 1 on the bottom. 15/4 is improper and that can be changed. So I can count by 4 3 times without going over. And 4 times 3 is 12. 12 plus 3 is 15. And my denominator doesn't change. So 3 3/4 is what you should have for your final answer for that one. And the last one, 12 times 1 is 12, plus 5 is 17/12, because your denominator doesn't change, times 4. And maybe you're thinking, Mrs. Trombley, I don't want to do 17 times 4. Well, you don't have to, okay? Because if you put a 1 underneath this 4, I can see, ooh, a 4 and a 12. 4 divides into both of those. 4 goes into 4 once, 4 goes into 12 3 times. So no, you don't have to do 17 times 4, you have to do 17 times 1. 17 times 1 is 17, and 3 times 1 is 3. And now I'm going to change that to a mixed number. 3 times 5 gets me closest to 17. 3 times 5 is 15, and 15 plus 2 gives me the 17, and my denominator doesn't change. Thanks for watching.